Okay, M&M's versus Skittles experiment by Sam, Brittney, and Courtney. So the Excel sheet that we have shows the sample proportions of the 95% confidence intervals in the intervals that contain 14% and 20% of the candies and the population differences. So this is the Excel sheet. We had 40 samples, which is shown in column A. In columns B and E, it shows the yellow M&M proportion and the yellow Skittles proportion, which were each out of 10. Columns C and F show the confidence intervals of M&Ms and the confidence intervals of Skittles, which shows the range that these could fall in with the proportions. Column D and G show if the M&Ms or the Skittles contained a value that could fall within the confidence interval values. And overall, there was 29 yellow candies of M&Ms that fall within the interval, and there was 37 yellow Skittle candies that fall within the intervals, with a total of a difference of 31 total candies that fall in the total range. The 95% of our confidence intervals contain the population proportion. Therefore, 38% of our confidence intervals should contain -6, but our data contains 31% of our confidence interval. This is because if we minus 14 minus 20%, which gets us -6, this then leads us to the 31%. This shows that 95% of our data is not represented in our data.
So for formal write-up, our abstract says that this project contains conditions, formulas, and graphs to show if Skittles or M&Ms has a bigger proportion of yellow candies. Our goal is to prove that a bag of Skittles has a bigger proportion of yellow candy than a bag of M&Ms. Our outcome came to be that the proportion of yellow candies in the population of M&Ms is less than the population proportion of yellow candies in Skittles. So the purpose of this project is to prove that a bag of Skittles has a bigger proportion of yellow candies rather than a bag of M&Ms.
Our confidence interval conditions are that it's a simple random sample from two independent populations. We took n times p for both 1 and 2, 1 being M&Ms and 2 being Skittles, and they're both greater than 5. The population size is 10 times greater than the sample size. We took a sample size of 10, so 10 times of that would be 100, and there would be at least 100 Skittles or M&Ms in the size of bags that we use to test. According to the data, we gather information that populations are not greater than 5. However, we will continue to test the yellow candies. For the formula, x1 is 2, n1 is 10, np1 is 20%, and x2 is 4, n2 is 10, and p2 is 40%. And yeah, pretty much says it right there. Conclusion. We are 95% confident that true difference in proportions between yellow candy in a bag of M&Ms and yellow candy in a bag of Skittles is between 3.9% and 36.1%. Thus, there is no significant difference between the candies because the interval does not cross 0.
So for our hypothesis conditions, they're simple random samples from two independent populations, which is M&Ms and Skittles. Again, we did a two-property test, and we did n times p and n times 1 minus p for n1 and n2, and n1 is M&Ms and n2 is Skittles, and they're both greater than 5. Our population size equals 10 times greater than a sample size. We took a sample size of 10, so 10 times of that would be 100, and there would be at least 100 Skittles or M&Ms in the size of bags that we used to test. So our hypotheses, our null hypothesis says the proportion of yellow candies in the population of M&Ms is equal to the population proportion of yellow candies in Skittles. And then our alternative says that the proportion of yellow candies in the population of M&Ms is less than the population proportion of yellow candies in Skittles. So our formulas in mathematics, I again wrote down the formula for the z, but we also did a two-prop z test. Our z ended up to be -0.97%, and our p and our p hat and our p value ended up to be 0.16, which does not fall in the rejection region. So our conclusion, we do not have enough evidence to reject our null hypothesis because our test statistic negative 0.98 does not fall in the rejection region, which is before negative 1.96 and after 1.96. The proportion of yellow candies in the population of M&Ms is less than the population proportion of yellow candies in Skittles.
Then if I don't stay for an entire actual